Alright, so for the molecule AZ3, negative charge from my worksheet, I'm going to start by adding up the valence electrons. I know that A has 7 valence electrons, and the Z has 6. And we got 3 of them. Oops. And then we also have this negative charge that we have to add in there as well. So that's another electron because it gained an electron. Gonna add all these up, and we have 26 valence electrons. And looking at my sheet, I know that the A is less electronegative than the Z, and we always put the less electronegative atom in the middle. And then we got our 3 lone pairs. Or not lone pairs, single bonds, sorry. Excuse me, I'm a little bit sick. Yep. Alright, and we're gonna put our 3 Z's on there. And then we're gonna start filling in our octets. It's faster like that. Alright. So these are all full. They all have their octets. We have 24 valence electrons if we add these all up. We need 26 though. The A only has 6 valence electrons. 2, 4, 6. So I'm gonna put a lone pair on top like that. Okay. Alright, so, oh, and we don't want to forget that it has a negative charge on there as well. So if we're looking at this molecule from a 3D standpoint, it's gonna look more like this. Okay, so we have our lone pair on top, and it's kind of pushing these guys down more. The molecular geometry for this molecule is tetrahedral, and we know that because it has 4 electron domains. And then the shape is going to be trigonal pyramid because we have that 1 lone pair on top. And then the bond angle between these molecules is going to be 109.5. Alright, so next we're going to be determining hybridization. I already wrote the answer here, but I just want to demonstrate how I kind of figured this out. Hybridization is determined by kind of how many atoms are connected to the central atom. And this one, or not atoms, but electron domains almost. This one has 4. So the hybridization for 4 electron domains is sp3. So in terms of polarity, this molecule as a whole is polar covalent. We know that because it's not symmetrical. And then going over the polarity of the bonds, the Z is more electronegative than the A. We know that. So the arrow is going to be facing towards the Z, and all the Z's will have a partially negative charge. And then the A will have a partially positive charge.